Okay, pre-cal students, I am back, hopefully with a little bit of a voice rest, and here we go. Let's go ahead and graph this function. Now, it looks a little complicated, and it probably is a little bit, but we can do this. First of all, you should know from Algebra 2, it's okay if it makes the problem a little easier to replace your f of x with y. So I'm going to go ahead and put y equals arc sine of x minus 1. Now, remember, students, whenever you simplify an arc sine, you usually use theta, unless the arc sine is equal to something, then instead you use whatever that variable is. So, I'm going to go ahead and rewrite this left side, but instead of putting sine theta, I'm going to put sine of y equals x minus 1. There we go. Okay, so just like that, I've taken this expression and I've rewritten it like this. Now, students, please don't forget something. Remember, whenever you're dealing with arc sine, your theta has to stay between, or in this case, it's not theta, it's y. So I'm going to call it your angle. Your angle that you're taking the sine of has to stay between what two numbers? Don't forget. Okay, students, very important you remember this. Negative 90 and positive 90. Okay, so we're going to quickly do a table of values to get us a good little sketch of the graph here, okay? And we're going to do it backwards. Usually you put values in for x. We're going to put values in for y, since we're taking the sine of y. And the values we're going to put in for y have to be between negative 90 and 90. So I'm going to start up here, and I'm going to put 90 in first for y, and then let's go a little smaller. We'll put 45 degrees in next. Then we'll get a little smaller and we'll put a 0 in, and then we'll start into our negatives. We'll put negative 45 and negative 90. Now, Mr. Earhart, how did you know to use those values? If you want to be more specific, you could have used 90 and then 80 and then 70 and then 60 and then 50 and then 40. You could have done that. Nothing wrong with that. But I'm pretty sure this is going to give us a good glimpse of the graph. And if it doesn't, we can always go back later and put more values in for y. Okay, so now be really careful here. Okay, watch carefully. Sine of y, we're going to put 90 in for y. Right here, we're going to put 90 in for y. So the sine of 90, let me grab my calculator. Sine, if I can get mine to work here, sine of 90 is 1. So watch carefully what I do, please. I have sine of 90 equals x minus 1. Well, the sine of 90 is 1, so I have 1 equals x minus 1. Then bring this negative 1 over, make it a positive 1, and 2 equals x. Alright? So when y is 90, x is 2. Not too bad. Pretty simple, actually. Now, let's put in 45 for y. So, now normally in the past, I want you to use exact numbers and use your special triangles, but since we're going to be graphing this, I mean, who wants to graph something like square root of 2 over 2? I mean, that's not going to help me. I need decimals, okay? It's one of the rare moments I'm going to want you to use decimals for the sine of 45, okay? But it's okay to use decimals in this problem. So I'm going to type in sine of 45, and I get this right here. I'm going to round it. I get 0.7071067812. So I'm going to put 0.707 equals x minus 1. Now bring the 1 over and make it a positive 1, and we get 1.707 equals x, okay? So let me move something here real quick, and let's write that down. So 1.707. So in other words, when I put 45 in, I got out 1.707. Now let's put 0 in for y very quickly here. So 0 in for y. I'm going to go a little faster now. Sine of 0 equals x minus 1. I'm going to go a little faster now, students. Sine of 0 is 0. So I have 0 equals x minus 1. Bring your 1 over, make it positive, and 1 equals x. So we'll put a 1 here, okay? Now, let's put negative 45 degrees in. So the sine of negative 45 degrees equals x minus 1. And the sine of negative 45 degrees would be negative 0.707 0.07 equals x minus 1. So bring your 1 over and make it a positive 1. Now use your calculator if you need to, okay? We're going to add 1 to that negative 7.07. And if you do that correctly, you're going to get positive 2.92. I'm just going to go ahead and put positive 0.3, okay? So when we put negative 45 in, we got out 0.3. Now, let's see what's next here. Let's go ahead and put in negative 90 for y. So sine of negative 90 equals x minus 1. And the sine of negative 90 would be negative 1. So we have negative 1 equals x minus 1. Bring your 1 over and make it positive 1. And you get 0 equals x. So there we go. Let me get a drink here real quick. And now, students, I'm really ready to graph this function. I mean, look at your value, so you can set up your coordinate plane correctly. Your x values are going to range from 2 to 0. Your x value. So I'm going to draw my x-axis kind of small. Now my y-axis is going to range from negative 90 to positive 90. So I'm going to draw it a little bigger. Okay. And I've got to think ahead here. I'm going to go ahead and put 1, 2 here, put a negative 1 over here, I guess, for really no reason, but anyways. And then I guess I'll go 0, 45 degrees, 90 degrees, and then negative, I'll use radians down here just to be creative. Negative pi over 4 is 45 degrees, and negative pi over 2 be negative 90, okay? All right, well, let's plot these points. The first point here is over 2 and up 90, so I'll put a point right here. The other point is over 1.7, so about right here, and up 45, so approximately right here. The next point is 1, 0, okay, a little bit of a curve there. And then 0.3, so we go over 0.3 about right here, and then down negative 45, so about right here. And then 0, negative 90 right here. Okay, now if you sketch the graph, it should look something like this, okay? And there should be a curve to it. There really should be. It hits here, and it kind of curves like this, and it hits here. Now, if this thing were to continue, okay, remember we have a domain between negative 90 and 90, but if we did not cut this thing off, it would continue to come back down like this and back down like this. And basically, if you were to flip it around, you would see a sine curve stretched out over a pretty big distance. Okay, so anyways, if you look in the back of the book, this might not look exactly like theirs because, at least according to my book, they stretched theirs out. What did they use? They stretched theirs out. They made this 90 and this 180. So it's kind of more compact if you look at theirs. But this is correct. Okay, this is correct. So, all right. Hopefully that made sense. If not, you might want to watch it again to make sure you really get it. Okay. Now, number 81 is really tough. So let's really pay attention here. Okay. Now, h of v and v, if it's okay with you guys, just to make it a little easier, I'm going to go ahead and use y. Just like back here in the last problem, I used y for f of x, and of course x. I'm going to go ahead and call this y, just because we're used to y, and I'm going to call my v x. I think that would help a lot, okay? Now this is a really weird problem. We got to graph this thing. Now, before we graph it, I'd like to do some simplifying first. Remember, this entire expression here is just an unknown angle, like a theta, okay? So, you can call it y, you can call it theta, whatever you want. Now, I'm going to come over here. I'm going to rewrite this as cosine of some angle is going to equal x over 1. So watch what I do. I'm just simplifying this side over here, okay? It's no different, students, if you were in Algebra 2 and you were given a quadratic equation like this. You would first simplify this right side over here and then go ahead and graph the parabola. Okay, well, same thing. We're going to simplify this right side over here. So here we go. I'm going to go ahead and draw my triangle, put my, I guess we'll call it theta. Put theta here. Cosine would be adjacent over hypotenuse. And then if you use Pythagorean's theorem and you solve for that other leg, you would get this right here. Trust me, you would get square root of 1 minus x squared. I'm not going to take time and do that. Okay, so what we've done is we've taken this whole entire expression here and we've defined theta as a triangle over here, as an angle in a triangle. So now I have y equals what? Tangent of theta. And I can quickly solve tangent of theta. So now y equals, what is tangent of theta? Well, adjacent, opposite over adjacent. So y equals 1 minus x squared all over x. Look at that. We had a big old function up here that had tangent in it and arc cosine in it, all kinds of stuff. And we just slowly, because we understand what to do with arcs, arc cosine, arc sine, arc tangent, because we know what to do with it, we wrote it over here, we simplified it, we got our theta written as a triangle over here, then we took the tangent of theta, and we're left with this. So this entire expression here is gone. We rewrote it like this, and this is not a hard function to graph at all. This is pretty much algebra 2. Okay, so here we go. Let's go ahead and graph this. Now we'll have to do a little bit of work, so be ready to work a little bit. Okay, now first of all, there is a domain we're going to have to respect. Okay, so I know in the past I've told you guys we're not going to have to worry about radicals, but in this problem here we are going to have to worry about this radical a little bit, because there's a domain. There's some numbers you cannot put in for x. Okay, so real quick, 1 minus x squared equals 0. Bring the 1 over and make it a negative 1, so negative x squared equals negative 1. Divide both sides by negative 1, x squared equals 1. And now take the square root of both sides, and x equals positive negative 1. So on a number line, put 0, put 1, put negative 1, and then we're going to test this region, then we're going to test this region, and then this region. Okay, so very quickly, if we test a negative 2, put a negative 2 right here into your square root. 2 times 2 is 4, and 1 minus 4 is negative. You get negative square root of 3. You cannot take the square root of a negative number, so this quadrant does not work. Now let's try 0. Put a 0 in. 0 squared is 0. 1 minus 0 is 1. Square root of 1. So this region here does work. Then over here we're going to test 2. If you put 2 in, 2 times 2 is 4. 1 minus 4 is negative 3. And you cannot take the square root of negative 3. So this region does not work. So we did all of that work to find our domain for x. And our domain is what? Has to be less than or equal to 1 or greater than or equal to negative 1. Now there's one other number that x cannot be. Look at your denominator. You never want your denominator to be 0, students. So x cannot be 0. So there, we did all of this work to find our domain. So now we're finally ready to go ahead and set up a table of values and put numbers in for x. However, students, please listen to me carefully. Sometimes when it comes to pick values for your x, when you look at your domain here, it's kind of hard to see what to use for x unless you put your domain on a number line. Now notice here x is supposed to be less than 1 and greater than negative 1. Okay, but x cannot equal 0, so I'm going to put 0 here. I'm going to put an open point. And so here's what I can put in for x. I can put negative 1 in for x, or any number between negative 1 and 0. And I can also put 1 in for x, and any number between 0 and 1. Okay, so here's the numbers I'm going to use for x, and see if this makes sense. To me, it makes total sense. I'm going to start with my positive side first. I'm going to put a 1 in for x. Then I'm going to I'm going to move along the number line. I'm going to stop right in the middle. That makes sense to me. I'm going to put a 1/2 in for x, okay? Then I'm going to get really close to 0. Now, I know I can't put 0 in for x because I'll get out undefined. But I'm going to get really close to 0. I'm going to put something kind of weird in. I'm going to put 0.1. Okay, now I'm going to continue along. So I have to jump over 0 and come to here. So I'm going to go barely past 0. I'm going to put negative what? 0.1. And I'm going to continue along my happy way here until I come to the middle. That'd be negative 1/2. And then continue on to negative 1. Now, to save class time, students, I went ahead and put all these values in for x already. I didn't want to take time to put a 1 in for x, then square it, then 1 minus 1 over 1, and all of that, and then put a 1/2 in. So put a 1/2 in with your calculator, square 1/2, whatever you get out, take 1 minus that, then whatever you get out, take the square root of it, and then whatever you get out, divided by x, which is 1/2, so divided by 1/2. That's going to take a lot of time, so I went ahead and did all the work for you. And if you put 1 in correctly, you will get out 0. If you put 1/2 in correctly, you will get out 1.7. If you put 0.1 in correctly, you will get out 10. I think 0.1 was 9.9. I just put 10. Negative 0.1 was like negative 9.9, so negative 10. Negative 1/2 was negative 1.7. And negative 1 gave you out a 0. So with that in mind, we're really ready to graph this thing. I'm just going to go ahead and give me some space so I can graph. Now my x values range from negative 1 to positive 1, and my y values range from 1.7 to negative 1.7. So I'm going to go ahead and put the graph like this. Now, again, students, if you compare your answer to the back of the book, for some reason, they put pi here, I believe. And so pi would not be radians here because, students, we're not using any degrees or any angles or any trig functions, okay? So why they use pi, I don't know, but pi would just be 3.14. And so this would be 1.57. There's really no need to do that. I'm just going to use regular whole numbers, okay? Not sure why they did that, but your first point is 1, 0, so over 1, up and down 0. Your second point is over 1/2 and up 1.7, okay? Now, your other point, you're barely over, and it shoots way up here to 10 somewhere. So do you not see what it's doing? It's going to come up like this, and it's going to curve a little bit. And I'm not a very good artist, as you guys know, but maybe if I start up here and work my way down, it's going to kind of come. It's getting closer and closer to the axis. It's going to break away, and it's going to come down here, and it's going to hit right here and stop, okay? Now you say, Mr. Arrow, how do you know it stops right here? Well, guys, we know that we can't go past 1. Remember our domain for x was less than or equal to 1, greater than or equal to negative 1. X cannot equal 0, so I know I can't go over here, so it's going to stop right here. Now, that's not a really, well, I'll leave that there for now. Okay, now, students, remember, hopefully you remember from Algebra 2, we have vertical asymptotes. I hope you remember that. And so this green graph is going to continue to get closer and closer to the y-axis, but it will never touch it, okay? So it will continue on and on, okay? Like this. All right, now let's come over here to this graph, and let's see. We'd have negative 0.1 is negative 10, so way down here somewhere. And then negative 1/2 is negative 1.7, and then negative 1 is 0. So the same thing again, students. We have pretend that your y-axis continued on down like this. The green graph is going to get closer and closer to the y-axis. It's going to curve a little bit. That's not a very good curve, is it? So I'm going to come here, curve a little, hit here, and then continue on like this. Okay? Not the best graph, but hopefully you get the idea. And by the way, students, that would be totally sufficient on a test or a quiz, okay? That would be totally fine, okay? All right. I hope you guys have a good, I hope this homework video has been a help to you. If you have any questions, don't hesitate to call or email.